gives you a sense of how this looks at scale. So what you're seeing here is actually cotton hulls from Texas in this case. It's a waste product. And what they're doing in our equipment is going through a continuous system which cleans, cooks, cools, and pasteurizes these materials while also continuously inoculating them with our mycelium. This gives us a continuous stream of material that we can put into almost any shape, though today we're making corner blocks. And it's when this lid goes on the part that the magic really starts. Because the manufacturing process is our organism. It'll actually begin to digest these ag wastes, and over the next 5 days, assemble them into biocomposites. Our entire facility is comprised of thousands and thousands and thousands of these tools, sitting indoors in the dark, quietly self-assembling materials, and everything from building materials to, in this case, a packaging corner block. So I've said a number of times that we grow materials, and it's kind of hard to picture how that happens. So my team has taken 5 days worth of growth, a typical growth cycle for us, and condensed it into a 15-second time lapse. And I want you to really watch closely these little white dots on the screen. Because over the 5-day period, what they do is extend out and through this material, using the energy that's contained in these seed husks to build this chitinous polymer matrix. This matrix self-assembles, growing through and around the particles, making millions and millions of tiny fibers. And what parts of the seed husk we don't digest actually become part of the final physical composite. So in front of your eyes, this part just self-assembled. It actually takes a little longer. It takes 5 days, but it's much faster than conventional farming. The last step, of course, is application. In this case, we've grown a corner block. A major Fortune 500 furniture maker uses these corner blocks to protect their tables and shipment. They used to use a plastic packaging buffer, but we were able to give them the exact same physical performance with our grown material. Best of all, when it gets to the customer, it's not trash, right? They can actually put this in their natural ecosystem without any processing, and it's going to improve the local soil. So why mycelium? Well, the first reason is local open feedstocks. You want to be able to do this anywhere in the world and not worry about peak rice hull or peak cottonseed hulls, because you have multiple choices. The next is self-assembly. Because the organism is actually doing most of the work in this process, you don't need a lot of equipment to set up a production facility. So you can have lots of small facilities spread all across the world. Biological yield is really important. And because 100% of what we put in the tool becomes the final product, even the parts that aren't digested become part of the structure, we're getting incredible yield rates. Natural polymers, well, I think that's what's most important. Because these polymers have been tried and tested in our ecosystem for the last billion years. And everything from mushrooms to crustaceans. They're not going to clog up Earth's ecosystems. They work great. And while today we can practically guarantee that yesterday's packaging is going to be here in 10,000 years, what I want to guarantee is that in 10,000 years, our descendants, our children's children, will be living happily and in harmony with a healthy Earth. And I think that can be some really good news. Thank you.